Assalamualaikum and greeting to all planners. My name is Mahmud Nabil. Today, I want to present about my final project 2. The title for my project is Design of Thin Electroplating Jig for Corpus Bus Bar in Flexible Connecting Industry. Slideshow contain introduction, problem statement, objective, methodology, result and discussion, and conclusion. Now, I will introduce a bit about my project. Thin electroplating is one of the widest used coating system in various industry, particularly in electrical and electronic industry. Electroplating is electromechanical process which metal deposit on a substrate is supplied to the buff chemical containing the metal of interest under the application of direct electric voltage across the ionide and cathodic side of the plating cell. In Subitek Islam Bahad, the thin electroplating system is already developed and jig for holding copper bus bar is being used to transport the tin to the copper bus bar in the electroplating process. The main product is to coat tin on copper substrates. The problem statement for the project is a new jig need to be designed which suitable with the size and the weight of copper bus bar using Fusion 360 software. The new jig need to design to fulfill the all parameters such as distance between the copper bus bar to the tin must be at least 153 mm or 6 inches to avoid defect. All of the jig design be analyzed using the static structure in ANSYS to compare each of the design in terms of effect of the force from the copper bus bar. Now, I will explain a bit about the electroplating process. Each of the workpiece will go through the working bay as shown in the figure 1, which contain cleaner, rinsing, activation, tin plating, tin pass, and hot immersion. Figure 2 show the top and the front view of the tub. The circle shape is the workpiece. At the front and the back of the workpiece contain tin which being hang at the tub. Figure 3 show the old jig which hold the cylinder copper. Figure 4 show the copper bus bar that which a new workpiece. The old jig is not suitable with the copper bus bar. The process and the simulation are as shown.
Dah. 1, 2, 3. Dua, 1, 7.
Objective for this project is to design the jig that suitable for the size and the weight of the copper. Next, to make sure it has suitable distance from anode and the tip of emission, and to analyze the effect of the force from the copper bus bar to the material and the design of jig. The method that I use for the project is as shown. First is sketch the design for the jig. Then create the 3D model of the jig using the software. Next is governing equation. After that, set the material properties for the jig in the software. Next is meshing using ANSYS software. Lastly, analyze the stress of the jig. If it not suitable, then sketch a new design and follow the method as shown. Now, I will show the result and the discussion. There are 6 designs of jig that has been designed using the software and be analyzed. Each of the design have been analyzed in terms of this formation, strength and stress. After being placed, the force from the bus bar. A selected design has been analyzed using 4 material, which is brass, copper, stainless steel and 316 stainless steel. For design 1, the copper bus bar is placed as shown in the figure. The design contains 2 holders which hold the bus bar. The analysis is on the stress that effect from the copper bus bar. Each of the color show the different amount of stress on the jig. The average stress for design 1 is 3.18 megapascal. The red color on the analysis show that the highest stress is applied at the center of the jig, which is 18.73 megapascal. The jig curve because the height force from the copper bus bar. For design 2, the copper bus bar is placed as shown in the figure. The design contains 4 holders to hold the bus bar. The average stress is 4.33 megapascal. The red color on the analysis is show the highest stress is applied at the center of the jig, which is 27.86 megapascal. The jig curve because of the height force from the bus bar. Same with the design 1. For this design, which is design 3, the copper bus bar is placed as shown in figure. The design contains also 4 holders which curve to support the bus bar. The average stress is 3.93 megapascal. A red color on the analysis show the highest stress is applied at the center of the jig, which is 33.89 megapascal. This design is a bit different because it has the curve at the holding part. For design 4, the copper bus bar is placed as shown in the figure. The design contains also the 4 holders to support the copper bus bar. The analysis show the average stress that have been applied to the jig is 3.04 megapascal. It does not have the red spot for the highest stress to the jig because it's the best design. For design 5, the copper bus bar is placed as shown in the figure. The design contains only 2 holders to support the copper bus bar. The red color on the analysis show the highest stress is applied at the center of the jig, which is 19.40 megapascal. The average stress is 5.12 megapascal. For design 6, the copper bus bar is placed as shown in figure. The design has the most contained holder, which is 8 holders to support the copper bus bar. The red color on the analysis show the highest stress is applied at the center of the jig, which is 13.17 megapascal. The average stress for this jig for this design is 2.62 megapascal. This comparison table show the design 1 has the highest distance from thin coating, which is 195 mm. Design 2 has the large surface touch with workpiece, which is 6,000 mm square. Design 3 has the highest material usage for making the jig. Design 4 has the low surface touch with the workpiece and high price. Design 5 has the low capacity to hold the workpiece. Design 6 has highest price and material usage. From the analysis and comparison, the most suitable jig is design 4 because the force from the boost bar does not give the high stress to the jig. Most of other design has the red part which give the high stress to the jig, but design 4 doesn't have the red spot. Design 4 also one of the least surface touch with the boost bar, which is 480mm square. It also has stable distance from the thin coating, which is more than 153mm. It also can coat uniformly because the boost bar is placed horizontally. Now, I will talk about the material analysis. The table show the comparison for price, density, young modulus, current conductivity, tensile stress, yield strength, and corrosion rate in sulfuric acid for the copper, brass, stainless steel, and 316 stainless steel. The figure show the analysis for brass on the design 4. The analysis show the average stress that had been applied to the jig is 3.0189 megapascal, and the highest stress is 49.76 megapascal for this material, which is brass. The figure show the analysis for the stainless steel on the design 4. The analysis show the average stress that had been applied to the jig is 3.0244 megapascal. The highest stress for the stainless steel is 51.04 megapascal. The figure show the analysis for the stainless steel 360 on the design 4. The analysis show the average stress that had been applied to the jig is 3.032 megapascal, and the highest stress is 53.915 megapascal. In conclusion, the analysis show that each of the design has its own advantage and limitation. The selected design, which is design 4, has been analyzed to be the best to hold the copper boost bar because it has least average stress compared to the other design. The design also has suitable distance from the thin coating and small surface touching to the boost bar. The material that is suitable for the jig is copper because it has the highest conductivity compared to the other material. Although copper has the high price and low tensile strength, but it can make the coating more uniform because of the conductivity rates.